Hi everybody. So we have a new project here that came in from a customer, and this is a pretty rare item here. It is a early to mid 1930s Jackson Bell model, I believe it's a model 62 Sunburst radio. And you can see the cabinet, the customer has actually started to strip some of the veneer off. He's going to re-veneer and refinish the cabinet, I believe. And he asked if I would go over it for him and get it working. Now, this radio is a little bit different than some of the ones that we've done in our previous videos in that it is not a Superhetrodyne. Now, what that means, for those of you who aren't into radio a whole lot yet, is that it doesn't have the same design of modern radios. In other words, you've heard me talk a lot about intermodulation frequency or intermediate frequency, IF. This does not have intermediate frequency. There is no IF, there is no mixer, there is no oscillator. You don't have any of those things. This is an older style of radio called a tuned RF. So this is kind of a predecessor to modern radio. Now, Superhetrodyne was actually invented by Edwin Armstrong in 1918, which is quite a long time ago, but it really didn't start to catch on in the commercial market until about the mid to late 1930s. So a lot of these, and the patent for Superhetrodyne was owned, I believe, by RCA, and anybody who wanted to use Superhetrodyne in their radios back then had to pay a pretty hefty licensing fee in order to use that patent. So this is one of the radios that's tuned RF. And what that means is the radio basically just takes the signal that you tune in from the antenna and amplifies it multiple times. So each stage of amplification is kind of like its own little radio tuner. And they all have to tune at the exact same frequency, or they'll actually get what's called a beat frequency, and they'll oscillate. So these are those old radios that will do that howling and whining sound if they're not properly set up. Now, the oldest ones, like the old Atwater Kents and so forth, had 3 individual tuning knobs, one for each stage. Okay, this is the more modern version where they took the 3 tuning capacitors and ganged them all together in one cluster. So when you turn this one knob, you're actually turning 3 tuning pots for 3 different tuning sections at the same time. And the idea is all 3 of them are supposed to be lined up perfectly with one another. So this is a really good way to learn where radio came from and how it evolved. So you've heard the old saying, those who fail to study the past are doomed to repeat it. And I'll kind of take and adjust that that little saying a little bit, and I'll say those who fail to study old technology and old electronics are doomed to reinvent them. So this is a really good learning opportunity for us to learn where radio came from and how it started out. This is one of the earlier types of radios, so it'll be very interesting to work on. I printed out the schematic, and I'll put this down here, and we'll go down onto it a little bit. And if you look here, this is all you get for a schematic in these old things. And you can see here's your antenna. Antenna goes to a adjustable variable resistor. It's just a big pot. And you notice the wiper of the pot's tied to ground. So really, all they're doing to adjust the volume of the radio is just shorting out the antenna. You can see right there. So we have that, and we have a little tone control. You can see here, where you're just taking a capacitor and kind of shunting it to ground, which is going to give you a tone control. It's very rudimentary, but it works. And then you notice these capacitors here, 1, 2, 3, 4. And these are all ganged together, see by the dashed lines. And then these are the actual ones that we use to make these make each of these capacitors match one another. Okay, so adjusting this radio once we get it working is going to be a lot different than adjusting a IF section, because basically we want to tune, we really don't care about an intermediate frequency. We only want to care that whenever we turn this capacitor and this capacitor, we want them both to make exactly the same resonant frequency in each of their respective circuits. So that's kind of how that's going to work. These are using very old tubes, and if you look, the tubes that came with this that he gave me, if you look closely, notice it has UY224. I don't know if you could see that. It's very hard to see. Let me get some light over here maybe. You can see a little bit. UY224. And a 224 tube, that is a military designator for a Type 24 vacuum tube, which is an old, I think that's an old tetrode tube. I don't think it's a triode. I think it's a tetrode. And basically, these old tetrode tubes, the original ones were built for the military, and they carried a designator of UY-224. Later on, when they went to the commercial market, they dropped the UI in the first two, and it just became a number 24. Same thing here with the rectifier. It's a Type 80 rectifier, which is a very common, off of the real old 1930s radios, a very common rectifier. And again, they call it a 280, but it's actually a Type 80. And you can replace these with a Type 80 and a Type 24. So if you look here, you have 1, 2, 3, 4, all of the same tube, Type 24s. The first three are actual amplifiers. The third one is, or the fourth one is being used as a detector, which is what's actually making the stripping off the half of the sine wave to make it into to take the audio out. And then it goes into an amplifier tube, which is a Type 45 or a 245. And interesting information about these, the Type 45 tubes, you can see this one doesn't look too healthy, but we'll see what kind of shape it's in. We haven't tested any of them yet. But the Type 45 is a very popular tube. Audiophiles people really like these tubes. Now this is only going to be able to put out in single-ended mode like this only about a watt or so of power. They're not very loud. But why these are so treasured by audiophiles is because they have such pure, clear sound. They have a really warm sound that's kind of unique to this tube type. So they're still highly sought after and collected, and these are actually pretty valuable tubes. So this radio should sound pretty nice. The other thing you notice, this funny looking coil here is a field coil. In other words, instead of having a permanent magnet on the speaker, they're using an electromagnet, which is nothing but a big coil of wire wound around an iron core to make a magnet. And what they do is, you know, we talked about the pi filter in my first ICO video here for the ST70. This actually acts two purposes. Purpose number one is it's the magnet for the speaker, but second of all, it acts as a choke coil between your two capacitors here to form a pi network. And that's what this is, to give you, you know, so you don't have radio hum, or have 60 cycle hum getting into your radio. So that's what that is. So here's your output transformer. If you look here, your filaments, so your 224s, and again, I think the 245, or the Type 45, I believe is a 6.3 volt filament, or a 5 volt, I can't remember. This is definitely a 5 volt filament on the Type 80, and then the 224s I believe are only 2.5 volt filaments. That's why you have so many filament windings on this transformer. This is your high voltage secondary, and it's tapped, so actually you have a full wave rectifier, believe it or not. So it should be between this choke coil and these capacitors, this should be a relatively quiet power supply. So this is actually a very good design back in the day. So here we are. This is where we're at. And we're going to get this thing apart, and I think we're going to start. The first thing you have to do before I agree to do any kind of work on this radio for this customer is check that a couple things are good. Number one, we have to check our transformers. If this transformer is faulty, or if that's going to be almost a deal breaker. If the output transformer is faulty, we can probably still find a suitable replacement for this. So that's not the end of the world. The field coil is another one. If the field coil is bad, we may have to replace this with either a resistor or a choke and then go to a permanent magnet speaker. And again, that would be a sad thing, because I really want this to work in its original form so that they can hear it exactly the way it would have sounded all those years ago. Being that this is such an old radio, we want to keep things as original as we can. Obviously, things like these resistors and capacitors are going to have to, be replaced. Another thing, if you look at these resistors, see 30M, that's an M, by the way, and when you see this funny looking little W, okay, their signifiers are a little different in the old days than they are today. 30M, okay, M is like Roman numeral M, meaning 1,000. So this 30M back then is what a 30K resistor would be today. That little W is actually their symbol for ohms. So what they're saying is this is a 30,000 ohm resistor. Okay? If you look at this, they have it written a different way here. They actually spelled it out, 30,000, and then they just put the little W symbol for 30K ohms. Okay? This one has a 300 and then the little ohm sign, so it's 300 ohms. This is 3,000 ohms. So if something were mega ohms, so you say, well, if it's 30M, what do you mean for meg? If it was 30 megs, they actually spell the word meg, M-E-G. So M would be 30K, or 30,000. Meg, M-E-G, would be 30 million, or 30 mega ohms. That's just the way that they did it back then. Any of you that are working on these really old radios, really old schematics, be aware of that. If you see a schematic and it says something like 30M, don't think, and then you measure it and it only reads 30K, don't go and change it out with a 30 meg resistor. It means 30K. Okay? So just understand that. You just kind of have to be aware of that in older electronics. Okay? So we'll get more into this schematic and we'll talk more how it functions as we take the radio apart and go through it and check all the things that are wrong with it. And as we work through this, you'll start to learn how they did things back then, and then we can kind of compare it to how we would have done it today with a, well, modern old technology, which would be stuff from the 1940s and so forth. Okay, so let's get this thing out of the cabinet. If we look right now, the grill cloth on this is really, really nice. I mean, like, immaculate. The case definitely needs some work, so we're going to have to do some work on it, or the customer is, because I think he's going to do the woodwork, which suits me just fine. We have a piece of trim missing. Okay. Somebody has worked on this. I haven't really torn it all apart yet, but you can see where a modern power cord has been installed on it. Okay. And pretty grungy, this is your B plus for your field coil goes through this. It's all black taped up. We're going to get rid of all this and put new wiring to make it safe. And back here's your field coil. So we're going to measure all of that. We're going to check our speaker. We're going to pull this out. This big square box here is the remnants of what used to be a capacitor. These are your two 8 microfarad capacitors used to be inside here. Now somebody, I believe, has cut that out of the circuit and tried to kind of bodge in a more modern electrolytic. All that's going to have to go and get redone. So let's get this thing out of the cabinet. I really don't want anything more to happen to this cabinet because right now in the state that it's in, it's very restorable. So we don't want to cause any more damage to any of the veneer or anything, so that they have the best chance possible to restore the cabinet. Because if this radio gets restored into really good working order, I'm sure they're going to want it to look just as good as it works. So let's get this out and we'll be back. Okay, something I want to take note of here while we're looking at this, and that is this note that's on the back of the radio. It says, before installing this receiver, determine the average line voltage. Remove the plate in the rear of the chassis and see that the fuse is inserted in the proper clips. For line voltages below 118 volts, the fuse should be in the 110 volt position. All higher voltages should use the 125. So this is actually a very cutting edge radio for its time, because most line voltages back then were about 110. So this one actually has a line matching, which is really good, because some of these older radios you have to put a thermistor or something in there to cut the voltage enough so it doesn't damage your transformer. And if you look at the schematic right here, you can see here's the fuse and here's your two clips, here's your two windings. So you have a 110 volt input winding on the primary, and then an additional winding to take it up to 125. So we want to make sure that it's wired properly. So I just wanted to take note of that. And as we take this apart, I'm going to finish untaping this wire here, and we're going to measure our field coil and our voice and our output transformer and our voice coil. So we'll be back. Alright, so we're connected to the field coil, and if you look, we have about 2.3K, you can see right there, which is good for that coil. So I'm pretty sure that our field coil at least is good. So now we're going to move over to the input of the output transformer, the primary side of the output transformer, and we're going to check that. These wires are so brittle and corroded, they just fall apart when you even touch them. So we're just going to have to play it by ear with that. Alright. Okay. And if we look at this is the primary of the output transformer, and we have 617 ohms. And again, that's good for the primary side, so that'll be perfect. It's good. The secondary, it's paralleled with the voice coil, so we're going to measure those, but that's not going to tell us if both coils are good. I'm going to say that they are, but we'll make sure though. We'll have to check that later. Okay, holding this on here, I have about, it's hard to see, but it's about 2 ohms. There, 2.2 is where it's stabilized. I can't hold it and run the camera at the same time, but I think our voice coil is good too. We'll pull the speaker later, but I think that's going to be okay. Everything in there is workable. So let's move the cabinet out of the way and get the chassis up here. Okay, as you can see with my new workbench layout, I mounted this monitor here, and I have an overhead camera so I can kind of look at the top of things, and it also connects to my microscope that I can use, so it should help us get some better shots of some of these things moving forward. But if we get down here, we can see that this radio is kind of rough. Right here we have the old capacitor, and if you look here, it is called a Potter condenser, and it says capacity is 16.25 microfarad. Now I'm thinking from all these wires that are in here, there's probably 2 8 microfarad capacitors, which is what we were seeing in the schematic. And we still have to, that kind of remains to be seen how that all is. The other thing I noticed is somebody drove a screw in here that I don't think belongs. We'll have to check that out. Obviously the chassis is going to need some derusting and some cleaning. These little coils here, we're going to have to be very, very careful with them. The wire on those can get so bad that, I mean, just looking at it funny can cause the wires to break. And again, that is a horrible thing if we have to rewind coils. Somebody has been in here digging around. You can see that these are kind of chewed up. See how they're dented down here, dented down here, dented here. Somebody has actually kind of tried to pry these open at one time, and that's caused some issues. So I'm going to just try to put those back together for now, keep them as is for the moment. Look at the front. Let's see here. We have some what's left of the patent tags. Okay, Jackson Bell Company. Looks like a serial number of, I don't know what that first digit is, but the last 4 digits are 6621. I don't know if that's a 06621. And then it has all of the patents, and you can see Radio Corporation of America, so RCA. So you can see, even though this is not a Superhetrodyne, a lot of the technology in this was still under license with RCA, and therefore they had to purchase the rights to all of these patents to be able to build this radio. Alright? So, just wanted to document that on the video. If we look, the tuner dial seems to be very free and easy to work. If you notice, it's just a numeric dial. So in other words, it doesn't tell us, these old radios were like this. They don't tell you the actual frequencies. It's basically a scale. It has a dial scale from 0 to 150. Or 100, yeah, 110. And you see that? So the 0 to 100 scale is what you would, how you would tune. You would actually set it, and then you would have a little chart that you would write down what dial scale was what station. That's how these work. So they weren't really accurate tuners. I mean, don't think you're going to set this dial scale and have it tune into whatever frequency you want. It's just not going to work that way. Okay, the knobs seem to be functional. They move pretty easily. This one feels kind of crunchy. I think it might have issues. This one here feels pretty good. So again, all these cloth wires are so badly damaged, they're all going to have to be replaced. Now I don't know, I do have some original Western Electric expensive cloth covered period correct wire, but I don't know if the customer will want to do that or want to just replace it with modern wires. That'll be up to him. Let's look underneath. So going underneath, you can see first off that somebody has replaced some things in here. We have an electrolytic capacitor that's not very carefully, not very safely put in here. You have what looks to be an extra choke coil that's been put in here at some point in time. I'm not sure what it's doing. Again, I'm not sure. This, I don't notice that in the schematic because they're using a field coil, so I don't know what's going on there. We have some components here that are kind of hanging off of a tag board. I'm not sure what that's all about, but you can see there's a resistor here. It's like an old carbon resistor. It might be like a grid leak or something. And one of these old color-coded capacitor or resistors, these old tubular resistors. We got lots of those going on here. Somebody has replaced a couple of the capacitors, you can see, with modern replacements. So I have this one right here and this one up here, 0.47, and can't see what this one is, 0.22. Alright, here's your tuned RF, and you can see this transformer is like falling off. We're going to have to fix that. So essentially this radio has had extensive work done on it. So as far as keeping it all totally original, that's just not going to happen. Unfortunately, you can see there's some extra wires that have been put in here. This transformer looks like it's seen better days, but we have to get this transformer out and in the open so we can clean it up and check it. These wires are definitely not going to be safe. We're going to have to be careful. So next thing we're going to have to do is check this transformer. This mounting in here, this looks like it's in the correct place. I have seen some, I do have some pictures of what an original one looks like that I printed out. And if you look here, you can see the transformer was originally mounted with the secondary facing out, and now they have it turned this way. So we have a lot of things we're going to have to deal with. First thing I probably would do is I would restuff that big can on the top up here, and you can see right there, restuff this guy, and hopefully be able to get this out of here. These resistors, we'll test them, but they tend to go really bad. They don't usually hold up. Most of the ones that I see are drifted way out of tolerance, so we may have to replace these. The funny thing is, these look like great big resistors, but believe it or not, these are probably only maybe a 1 or 2 watt resistor is all they are. This big one down here might be maybe a 2 or 3 watt resistor. None of them are very big, okay? They're just physically large size because that's how they built them back then. So essentially this is going to be a start from scratch to rebuild it, unfortunately. So I'm going to take all of this information, and one last test we would have to do before we could determine whether this is fixable or not is to go through, and we would have to measure all of the coils to make sure they're all good too. Now, if one of them's bad, sometimes you can fix them, sometimes you can't. I'm not much of a coil winder when it comes to these RF coils, but that's another thing we'll have to look at. So let's stop this video right here for the moment, and we're going to get with the customer and see what they want to do, and if they want to go forward and repair this. We're going to test the tubes. We're going to test the tubes as well. I'll give him a report of what all it needs, and then we'll come back and find out what he wants to do. Alright, so I finished testing the tubes here, and this is the result, which isn't very good. The Type 80 rectifier tests perfect. It works really well. It's good. 2 out of the 4 Type 24 tubes are bad, totally bad, and 2 of them read weak but do read. Of all of them, this one's the best. You can see I marked it. It's got a gain of GM of conductance of 550. It should, the rejection point is 700, okay? So this tube is weak but functional. It would work in the radio, not perfectly, but it would work. The next highest one was this one, which is 350, which is now getting very weak, but it still probably would make the radio play, just not well. which is this is one of the antique globe style tubes. This is an original. And then these two were bad. One of them was completely bad, which is this one. Didn't have any, just barely any deflection at all. It's just the tube's bad. And this one right here was only a 200 red 220, which is very, very low. This probably would not play properly. So you basically need, and the Type 45 was completely shot. It got warm when you turned it on, the filament came on, but there is zero emissions. Once in a while it would deflect up a teeny little bit, but you know, pretty much this tube's dead. So I guess with the exception of the Type 80 rectifier, I would recommend all new tubes, which would be 4 of the Type 24 tubes and 1 of the Type 45s. Now the 24s can be had online pretty inexpensively. The Type 45s a little bit more. Again, they can be found like on eBay, and tube stores sell them and things. But to get this radio playing, they're going to definitely need replaced. The last but not least is I'm going to remove the transformer from the radio and test it, and if it's good, then I'm going to make a recommendation on what it's going to cost and what it's going to take to repair it. So I'll do the transformer test probably last, and then I'll post this video, and then we'll wait for the customer to decide what they want to do. And if they want to go ahead and repair it, we'll move forward as long as the transformer is good. And if not, then we'll get her button back up, and this will be the final part of the video. Alright, you all have a great day, and more to come later. Okay, good news and bad news. Good news is I think the transformer is good, at least statically, you know, measuring, just ohming out the coils. Bad news is this is not the transformer that belongs in this radio, and the dimensions of this transformer are actually different than the one that belongs in here, which is why they drilled extra holes and mounted it in the way they did. This one's actually too deep for this particular radio. Now what that does to us is that by not being able to mount this in the correct way, man, I don't know. This was definitely not safe the way it was mounted, and it was coming way too close to, you know, to these tube sockets, which are just sticking right out, you know, where you can hit them. So again, maybe I'll have to come up with something to be able to fit this into here somehow. Maybe I may have to rearrange some furniture in here, I don't know, or maybe it won't work, I don't know. But definitely something we're going to have to talk over with the customer and see what they want to do. So until we get some answers, I think this is the end of this video, and we'll see what happens. Alright, so we got the transformer out. Again, it is not the right size transformer for this device, but the voltages and everything are going to be okay. So we just have to find a way to mount this thing in here. I checked it all out, and the transformer is actually good. All the voltages are good. The transformer is fine. It's got some rust on it, as you can see, and we'll have to clean that up, but it's very cleanable. I made a printout of the actual transformer and the taps, and basically this is how it's going to be. So here's your 0 volts and your 125. So this will be your input for your primary. This one won't be used because we have 125 volts AC here. We have the 2.5 volt, and it's center tapped, and that's going to go to your Type 24s. And then you have another one here that's going to go to your Type 45. Okay, I'm back. And then like I said, this one is actually going to go for the Type 45, and then down here is your B plus voltage, which is unloaded with, with no load on it, I'm getting about 850 volts with center tap. So it's actually about 425 from here to here. So, and that'll drop down some when you put a load on it. But they're all there. All the voltages are there. It's good. There's no shorts. There's no problems. So my thought process right now is to get some, some angle bracket of some sort and kind of modify it on each side with some angle bracket. And then we're going to try to attach it in there this way with the taps facing down towards the bundle here. These wires, some of them are kind of, if you look, they're a little bit brittle, I should say. Like this one's brittle. This one here is still pretty pliable. You can see the cloth moving around on it, and it's not bad. But that being said, this old cloth covered wire makes me nervous. I mean, you see what happens at the bend points right here where it bends. You can see where it's just, look, falls apart. So probably this is going to end up being a rewire. These copper shielded wires I'm probably going to leave alone. I think you can, if I can zoom in here, you can see the little copper shielding. That stuff we're going to keep intact because it's good. So, and that's it. Anyhow, this video is getting way longer than I ever intended it to. So I'm going to get this one posted up there so you all can get started with me here. And then when I come back, next video, maybe we will have made some progress on this thing. So, all right, that's it for now. For real this time, I promise, honestly.